Thank you for tuning in to our webinar, where we will discuss the manufacturing operations management journey of Milo's tea. Over the past 2 years, Milo's has deployed multiple smart manufacturing solutions by leveraging the TrakSYS MES MOM platform. As questions come up, please enter them into the GoToWebinar console. At the end of the presentation, our panel will address some of your questions. Answers to all questions will be emailed after the broadcast, along with a link to the recording of this webinar. I am your moderator, Scott Klages, a senior manufacturing consultant with 24 years of experience at Parsec and 38 years of manufacturing experience. Today, I am joined by Scott McDaniel with Milo's Tea Company and Richard Phillips with Polytron. Scott, over to you.
Hi, I'm Scott McDaniel, and I've been a subject matter expert in operations efficiency via technology for 15 years. I've been at Milo's in this capacity for 3.5 years and have taken Milo's from manual data tracking of OEE to full MOM capability on 6 production lines and 2 facilities running 24/7.
Hello, and I'm Richard Phillips with Polytron, where I lead our Smart Manufacturing Solutions group. I've been with Polytron for 25+ years, during which time I've implemented many different types of manufacturing solutions across multiple industries. Polytron served as a system integrator for this implementation, and we worked alongside Scott McDaniel and others at Milo's Tea to architect and deploy the solution described in this case study.
As an introduction for your host for this webinar, Parsec has been in business for over 30 years with an exclusive focus on developing MES MOM, Manufacturing Operations Management software. Parsec's TrakSYS software provides the full range of MES MOM applications from a single unified solution platform, resulting in the ability to rapidly and cost-effectively implement solutions that can solve a wide range of business problems. TrakSYS is deployed in over 100 countries and in virtually every industry for batch, continuous, and discrete processes. Scott, can you tell us about the Milo's Tea business?
Sure. Founded as a hamburger shop in 1946 by Milo and B. Carlton, Milo's Tea is a family-owned, certified women's business enterprise headquartered in Birmingham, Alabama. We manufacture, distribute, market, and sell all natural, fresh brewed teas and lemonades throughout the country. In 2014, Milo's nearly tripled its distribution from 13 to 35 states, and today we distribute product in 45 states. This exponential growth and high customer demand for our product has led us to focus on improving the productivity of our current facility and building a second facility in Oklahoma.
Richard, can you tell us about Polytron's focus as a systems integrator?
I'll be glad to. Polytron has been delivering successful solutions to manufacturers for over 35 years across many different industries. Polytron's smart manufacturing team specializes in helping manufacturers architect and deploy their digital transformation strategies with a focus on delivering incremental, measurable business value along the way. Polytron has been a Parsec partner for over 10 years, delivering TrakSYS-based solutions for many different manufacturers during this time. In addition, Polytron has expertise in designing and delivering solutions in automation, industrial networks, cybersecurity, machine safety, and process and packaging systems. Polytron was named Control Engineering's 2019 System Integrator of the Year and is certified by the CSIA, which is the Control System Integrators Association.
So Scott, with the tremendous growth Milo's Tea is experiencing, I imagine it created a lot of demands on the manufacturing team. Can you describe those challenges?
Sure. As demand increased, we needed to squeeze every bit of efficiency out of our existing lines in order to buy time as we consider further expansion. We had several challenges that we needed to overcome. The main issue was that we had no real visibility in how our lines were running, and therefore understanding of how much more production capacity was available. Sure, we could do the simple math based on the rated capacity, but the insights of how to maximize capacity were lacking. It became an opinionated discussion on what we needed to do and not data-driven. Our key challenges were, our insights were based on manual recording of data, which was unreliable, prone to error, and time-consuming for the operators. Transferring this data into reports to present to management was also time-consuming and not timely. The organization had no visibility into how manufacturing was performing in real time, and therefore not able to immediately address issues that arose. Also, we had several different data silos that made it difficult to see the whole picture.
Scott, the challenges you described are common to most plants that are still running their shop floors using spreadsheets and whiteboards. Without accurate data, you're forced to make a lot of decisions based on feelings and opinions. Once you recognized the need to modernize your shop floor, what goals did you set for the organization?
Our leadership understood the value of using data to improve productivity, so we knew we could do better, much better. So we started an initiative to address these changes. Our immediate goals were, first, to increase production. We needed a system that would provide real-time visibility so that we could focus on targeted improvements that would provide the highest value. We needed to shift to a real-time, data-driven organization. Second, organizational visibility. We needed a platform that allowed users across the organization to get real-time visibility and make quick decisions based on reliable insights. And three, one single platform. We knew this was just the beginning, so we needed a platform that would grow with us. We knew that we would eventually want to pull in data from our other systems to have contextualized information. Initially, we planned to implement OEE and downtime tracking, aka TrakSYS performance management, with the goal of quickly improving our production capacity. We selected TrakSYS as our MOM platform and Polytron as our integration partner. The results from this first phase exceeded our expectations in terms of increase in OEE and thus additional production generated. The success in turn fueled 8 more phases of deployment over the next 24 months. The value of having real-time actionable information became apparent very quickly for all the users, including operations, management, maintenance, and senior leadership. To summarize our implementation phases, initially we deployed performance management on 3 filling lines, including automatic data collection from the PLCs, with the purpose of reducing equipment downtime in order to increase throughput, which in our case is more cases produced. This was followed up by integrating TrakSYS with our ERP system to automatically download production schedules in order to get rid of paper schedules and the associated errors and delays that goes with that. Next, our empty bottle area is not PLC controlled, so Polytron recommended we use Parsec's IIoT smart sensors to feed empty bottle counts directly into TrakSYS. This helped us identify and reduce waste we were seeing in that area. Our 4th phase was to implement the TrakSYS historian so that we had further insight into key process and packaging parameters such as temperatures, pressures, etc., which helped us identify issues and trends in addition to better controlling quality in our batching process. Not shown on the slide was a 5th phase where we implemented performance management to our 4th line and expanded automatic data collection to additional machine PLCs. For the 6th phase, we had a legacy maintenance management system that was difficult to use and not connected with the rest of our data. As we looked to replacing it, Polytron recommended that we consider using the TrakSYS platform. We went through the process of developing our requirements and evaluating replacement platforms, including using TrakSYS. We decided to use TrakSYS given that we did not need most of the functionality provided by the point solutions we considered, and found that the benefit of having it on the TrakSYS platform with the same user interface, dashboards, reports, etc., made a lot of sense. The increased production throughput allowed us to meet demand while we built our 2nd factory, which is going into production this month. In fact, we went live and had a ribbon cutting yesterday. We are underway deploying our TrakSYS solution along with the learnings and best practices we developed from our 1st factory to this new factory. We'll be able to see both plants through overview dashboards and drill down to the data for each plant. This will be very valuable as most of our support services and senior leadership will be in Birmingham. As part of our 8th phase, we recently deployed performance scoreboards across machine centers to give specific information to operators on the plant floor so they could see how the functions they were doing rolled up to the overall line and plant OEE numbers. For example, at the box former, where cases are packed with individual gallons, we gave them a cases per hour target based on the theoretical rate we use for the performance component of OEE. Now they can see how their actual numbers fared versus target for the last hour and the current hour. We did similar scoreboards throughout the functional areas in the plant that Richard will speak to later.
Oh, that's terrific, Scott. Let's now discuss the solution architecture used to support these applications. Richard, can you describe the architecture and provide some more detail regarding the key project phases?
Absolutely. Thank you, Scott. So to start off, we deployed the TrakSYS software and the SQL database on a new dedicated virtual machine. The VM was placed on the plant floor network so that it had easy access to the plant floor data sources and other systems. TrakSYS collected PLC data through an OPC server. In this case, we used RS Links. And then Polytron installed our data collection file into each PLC to collect the first out faults, production counts, process parameters, and other key data points. This also allowed us the network to access the IoT smart devices that Scott referenced. And then for ERP integration, Sage was set up as a linked server to the TrakSYS SQL server. So plant floor users were able to access the system using workstations on the floor as well as wireless tablets throughout the facility. And firewall permissions were set up to also allow the office users to access all of the TrakSYS dashboards, the drill downs, alerts they received, and reports through their corporate network. All right, so let's dive into the details of each phase that Scott McDaniel went through. So the first phase deployed was performance management for the 3 filling lines with automatic data collection from the PLCs. As mentioned earlier, line 4, shown on the above dashboard, was added as a subsequent phase. So some of the key components of this phase included OEE is calculated and stored with contextual information such as shift, job, product, hour, etc. Components of OEE such as availability, performance, and quality are also captured. Extensive drill downs are available if the users want to see the details behind each calculation. And then graphs are also provided to allow easy digestion of the information for identifying problem areas. The same information is available through multiple dashboards and reports to allow users to quickly pinpoint and address issues causing line downtime. Milo's T personnel were able to leverage this information to make dramatic increases to productivity, which demonstrated to senior leadership the business value of this real-time accurate data collection and analytics. So the short return on investment of several months from this initial phase led Milo's T to accelerate deployment of the additional phases, which we'll cover here, in order to gain even greater value faster. The second phase was ERP integration for downloading production schedules automatically in order to eliminate paper and associated errors and delays with this paper. Scheduled jobs were pulled electronically from the ERP system based on each line they were assigned to. Some of the scheduled jobs were not assigned to a specific line, so the operators were able to assign those jobs to the lines capable of running that SKU or product within TrakSYS. The scheduler is able to download the production schedules multiple times per day in order to accommodate any late additions or changes to the schedule, which is pretty common. When it is time to start a new job, an operator merely has to select the next job in TrakSYS and then run it. And then this phase solved many issues operators were having with trying to find the next job on a printed form, making sure they had the latest version of the schedule, and then transferring these numbers into TrakSYS manually. It also allowed the scheduler to make changes electronically without needing to republish a new paper schedule and then manually taking it out to the production lines to replace the old schedule. The third phase was implementation of the TrakSYS IoT smart devices in the empty bottle area to count bottles. So production was having an issue identifying and tracking empty bottle waste to determine where empty bottles were being lost, along with timing and quantity. Since the empty bottle area was not PLC controlled, we decided to use these smart sensors to bring the photo eye counts directly into TrakSYS without any additional wiring other than the 24 volts DC for power. The smart data collectors allowed us to collect almost any digital or analog signal directly in the TrakSYS without the need for a PLC or network drop. Devices were placed at the beginning and the end of each empty bottle line to capture the total bottles unloaded and the total bottles entering the fillers. Counts were monitored in TrakSYS to determine when a stop would occur, in addition to losses. Milo's Tea was then able to more closely monitor the number of bottles entering each line and proceeding to the fillers in order to have more accurate accounting of waste. And this is just an example of how these additional enhancements can be very easily added once the TrakSYS platform is in place, and then also with the versatility of these smart devices.
I'll jump in here for a minute, Richard. One thing you didn't mention is how we use the smart devices to run line 4, which we mentioned was added as a phase after the initial installation. When we added line 4 in the plant, management obviously wanted it on TrakSYS like the other 3 lines, but we didn't have a PLC in the filler. So because we had already used the smart devices for the bottle room to measure waste, we thought we might be able to use them in TrakSYS for running the line. It turns out we were right. The smart sensors allowed us to get the new line up and running, gathering data in a very quick manner. We used 3 smart sensors attached to photo eyes to run the line. One to determine a starved state, one to determine a running block state, and one to get the count of the bottles. The solution worked great, and we still, a year later, run line 4 with smart sensors.
Great point. Thank you, Scott. So the next phase was to implement Historian for process and packaging time-based data analysis. So process values from the brewing process are captured for later analysis. This includes temperatures, batch times, etc., in case batch conditions need to be further investigated during or after a batch is made. The counts are captured for reporting of time average production counts, for example, bottles per minute. And then equipment states are also captured to allow easy graphing of the process values against the equipment states together to see the correlations. The historian provides easy access to historical data trends and allows personnel to better understand any variations and anomalies. So Milo's Tea was looking to replace their existing maintenance management system, given that it was not user-friendly. They had known issues they had to work around, and it was not well integrated with their other more modern solutions. They developed a list of requirements for the replacement system, which Polytron then helped evaluate. We determined that TrakSYS would not only meet all of the requirements, but also provide a common user interface and database, along with benefiting from the existing ERP integration and the tablets and scoreboards that were already in use. Some of the key features of the solution include, so operators can initiate a maintenance request in TrakSYS, extensive ability to schedule recurring tasks such as preventative maintenance, ability to trigger events based on process values if necessary. This is a key benefit of leveraging the existing platform that already has the process variable and other data available. And allows for tracking of spare parts inventory. A user can quickly look up a part and see its location, how many are in hand, how many are in order, and what preventative tasks that part is being used for, or is typically used for. Ability to create purchase orders, so when parts are needed, that then are automatically transferred to the ERP system. So some of the maintenance management dashboards are shown on the slide. These include work order statistics and labor hours shown by priority, current work order status of each line, and then a part lookup screen. All of the previous phases were first deployed to the Alabama facility, though we architected the solution knowing that additional facilities would be coming online over the next several years. So we wanted to make sure we could easily deploy the solution to future facilities, in addition to setting up corporate-wide dashboards and reports to allow senior leadership to see all of the facilities at once while still being able to drill down into the data for each facility. The rollout to the second facility is complete, as Scott mentioned. Some of the key points to note are: 1, Milo's team wanted the TrakSYS solution in place at the start of production so that they could have visibility starting on day 1. The PLC system tracking files were added to the machine PLCs to collect downtime, counts, key parameters, etc. The maintenance teams were trained to use the new maintenance system before construction was completed. And then as new MOM functionality is deployed to the Alabama facility, it will then be seamlessly added to the Tulsa facility. Having this common platform and solutions at both facilities will help ensure best practices are followed and provide greater visibility to all of the stakeholders. Next, scoreboards on large TVs were deployed across machine centers for real-time shift performance. The operations team had requested more targeted dashboards, as Scott mentioned, for each group of operators to make the information more actionable for the operators. So the scoreboards included a plant overview showing detailed metrics for each line, a brew overview showing detailed metrics for each area of the brew system, filler scoreboards showing the performance metrics and product image running on each filler, and then the same for the case packer scoreboards showing performance metrics and product image running at each case packer. Each one displayed the real-time data that was related specifically to that area of the plant and encouraged operator engagement to improve productivity. So in summary, the leadership and plant personnel can now go to a single platform to get a real-time view into how they're performing from a high level all the way down to the specific piece of equipment. Real-time manufacturing visibility within context is available to all users so that problems can be addressed quickly and correlations are better understood. And the organization shifted from shifted to more of a data-driven and less of an opinion-driven organization with greater alignment on necessary steps required to make these improvements. Here are some of the few additional dashboards. You can see a dashboard from the maintenance management solution. These show you how things look, like work order statistics and labor hours by priority. You can see the current status of each line and weekly metrics for maintenance work orders. And then at a glance, plant personnel can see what is being run, how fast it's running, and their OEE broken down by day and shift. You can also see the value of having many different types of data on the same platform. And now I'll hand it back over to Scott to review the results generated from this solution.
Thanks, Richard. Yeah, let's talk about the results. Probably the most important bullet is that the initial product cost was recouped within around 6 months. We saw a significant increase in OEE from the time the system was initially rolled out. Before we rolled it out, the OEE number that was being published for manually calculated downtime was in the upper 70s, low 80s. The main flaw in the manual method was the unofficial threshold for time that was being used. If a piece of equipment wasn't down for more than 5 minutes, they basically didn't track it. In comes TrakSYS, tracking everything every second, and the numbers took a hit. When first installed, the OEE, the correct OEE coming from TrakSYS was around 55 to 60% for each line. Operations management was convinced something was wrong with the system. Obviously, there was nothing wrong, just way more visibility into downtime. So with that new knowledge, all the data TrakSYS was giving us as backup to the numbers, OEE started to climb. And today we have a target on all lines of 78%, and we consistently hit right around that number now. This increase led to a substantial increase in the amount of product that they could get shipped out without any significant changes in assets. With the OEE becoming such a visible and important KPI, we are able to offer incentives to operators to improve and maintain high OEE and therefore high production. The improvement in line efficiency meant that less scrap was created due to long downtimes. And finally, because they were able to get so much more production out of their existing equipment, they were able to put off the construction of the new facility by 18 months. Let's talk a second about future phases. There are several additional phases we are currently prioritizing. One is performance management phase 2. As we described, most of our major machines, roughly 16 total, including labelers, case packers, palletizers, and stretch wrappers, automatically provide data to TrakSYS. We now more clearly see the value of adding the remaining assets such as cap sorters, bottle coaters, case and pallet labelers, conveyor systems, and other machines not connected to TrakSYS. So we're looking to add another 20 to 30 assets to TrakSYS for even greater visibility. Second would be a warehouse management system, a WMS. As we did with our maintenance management system, we're currently evaluating options to replace our WMS and are considering leveraging the TrakSYS platform for that functionality as well, for the same reasons we described as part of our maintenance management evaluation. Though we've already started leveraging TrakSYS for an initial phase of this work. First, we needed fast confirmation of the pallets with product going into our warehouse cooler so that we could reconcile this with our current WMS and ERP systems. To accomplish this, Polytron implemented a barcode scanning solution connected to TrakSYS to send barcode information to our ERP where we perform the reconciliation. This in turn exposed another issue where full product pallet labels would occasionally be misapplied, resulting in barcode misread. We speculated on the cause of this, but we needed data to make sure. Polytron is now implementing an IP camera solution that will connect to TrakSYS and capture a picture of the label when we have a barcode misread. This information will help us identify the root cause and take corrective action. We're excited to use this same IP camera solution in many other areas of the plant and many other capacities, including being of great use in our new plant, given that we will not be on site to see the issues. Richard, can you cover the other two phases shown?
Sure. We constantly are looking into new opportunities where Milo's tea can further leverage these Industry 4.0 solutions to improve the productivity and drive even greater business value. Two that are worth noting that we see great potential with are algorithmic scheduling and visual workflow, which are the latest functional modules developed on the TrakSYS platform. Algorithmic scheduling will allow Milo's tea to use predetermined rules in real-time data to optimize production scheduling based on many different factors, including customer demand, inventory levels, line availability, changeover, etc. This provides a framework for best practices and greater intelligence in their scheduling activities. With the second factory going live, it will be more critical to optimize and coordinate schedules more dynamically. And then visual workflow, which will connect all manufacturing functions with a digital visual representation of all interactions between the users and the manufacturing activities. This will allow everything to be tracked and optimized while providing visibility to the entire organization as permissions allow, of course. And then lastly, I'll mention that we are, with all of the data already in TrakSYS, adding traceability from materials and components all the way to warehousing becomes much easier endeavor if and when this need comes up. Now I'll hand it over to Scott Klages to wrap things up.
Thank you, Scott and Richard, for sharing how TrakSYS helped optimize operations at Milo's Tea. Today, we've seen how TrakSYS can connect to various data sources to deliver accurate, real-time data and key performance indicators to the plant team, facilitating a real-time response to issues and enabling improved decision-making. These are critical tools for lean, continuous improvement activities. Milo's Tea was able to use these tools to produce amazing capacity improvements. Notice that the initial application was expanded in phases, so the plant team was not challenged with too much change at one time. Finally, you saw how TrakSYS provides a unified MOM platform, delivering a variety of solutions which improve the productivity of the business. So with that, we're going to jump into the Q&A portion of the webinar. So please don't be shy. enter your questions into the GoToWebinar console. I just see a couple questions there right now, so there's a good chance we can get to your question if you go ahead and enter it. Let's see, we do have a question. Scott, this would be, I think, addressed to you. Why was TrakSYS selected as the MOM software platform?
Well, Scott, there were many reasons we chose TrakSYS. I think first, we really like the dashboards and the user interface. Operators are able to easily move around the platform to perform the tasks they need to do, and also view the dashboards to get quick, meaningful, actionable data. Second was scalability. As we've talked about already, we knew we wanted to grow our use of whatever system we chose. TrakSYS offered the scalability we were looking for. Third was probably the versatility to work with our existing infrastructure without any major upgrades. We were able to install TrakSYS and start getting data quickly. Going along with that was the relatively quick startup time. We were able to plan, design, develop, and start using the system within a matter of a few months.
Oh, terrific. Yeah, thank you, Scott. Here's a question. Richard, I think this would be a good one for you. We are just starting to look into our company's Industry 4.0 strategy. Do you have any additional recommendations on how we should get started?
Yeah, certainly, Scott. That's a great question because there's several published studies or surveys out there where 80% of these proof of concepts fail, or there's this proof of concept purgatory that's common in the industry where you can see in this case people don't move past the first phase. So there's a couple of key points that we make sure to talk about with our customers. One of them is focus on business drivers first. So we're trying to solve business problems. We're not trying to implement cool technology. That's more just the side benefit of it, if you will. So we're trying to identify what are the big business problems and which ones can we solve at the lowest cost to have the highest impact. So figuring out your initial phase so that you have that lowest cost, biggest impact demonstrates to the business leadership that technology can solve problems. And that helps. In this case, you saw it helps fuel all of the subsequent phases. So that would be probably the first thing. The second, some of the other considerations we have is make sure to gain alignment with all the stakeholders that are involved. It's easier if everybody is quote unquote on the bus and moving in the right direction and helping the project be successful. And just like Milo's T did, consider your technology stack. So part of the value of digital transformation is having the data contextualized and seamlessly integrated. So having a lot of different silos of data that you have to figure out how to integrate the different silos becomes problematic. And of course, you don't want to force solutions into a platform where it doesn't make sense. For example, we would not do any ERP functions in TrakSYS in this case. But simplifying your technology stack will certainly help with simplifying your deployment, the training, user interface, alerts, contextualizing information, and so forth. And of course, your ultimate goal for the first part is you want to show an ROI, and you want to show a powerful ROI so that it helps, feed funding into all the subsequent phases.
Richard, that's great advice. I think that focusing on the business drivers first is so critical because MES MOM has such a wide purview. There's so many things you can do with it, but you almost never go wrong when you focus on the key business drivers. All right, we've got a question, Scott. I think this would be aimed for you. How well did the operators and floor leaders adopt TrakSYS? What do you attribute the adoption results to, and for what I assume was a very successful implementation? So how did the operators and floor leaders adopt it, and what did you attribute the adoption results to?
They adopted it pretty well. It took a little time at first, but they adopted it pretty well. I think one of the reasons, or one of the main reasons they did adopt it so well was we gave them kind of an ownership of the system, because when it boiled down to what they were doing, the efficiency in which they ran TrakSYS, which we did it from our filler room, the efficiency which they did it led to making T more efficiently. So we we trained them well. The supervisors were along through the development of the system and had input to, how the system would look, what they would need to be able to input and things like that. So when it got time to go live, they were ready. And so the training and the involvement on the front end was a big help for that. Second was the ownership of they were the ones running the line. And when I say they were the ones running the line, the people in the filler room were running the line and TrakSYS, because we had iPads out at every line, and they would enter the work orders, they would do the changeovers, put the new work orders in. They would, in our case, with the lack of real functional PLCs, we had PLCs, but they weren't giving a lot of downtime reason codes. In our first facility in Birmingham, the operators in the filler room also had to run TrakSYS by showing and inputting what the real reason for the downtime was. It would start as a stopped condition, and they would go and choose the correct condition, bottle jammed or whatever the reason was. They would go choose that and enter it into TrakSYS. So all that lumped into why they adopted it pretty well, I think, goes to say how they adopted it and took TrakSYS in as their own. They considered it an operations tool, and they have been for about 3 years now using it. So it went well at first, but it took them giving them ownership of the system, I think, to wrap all that up. So.
Yeah, Scott, I think that's excellent advice. You definitely want to have the associates on the floor involved right from the get-go, so that they realize this is actually a tool to help them do their jobs. And that's especially critical if you have a union workforce. You've got to make sure they're involved and buy in right from the get-go.
Exactly.
So, terrific. All right, Richard, let's aim this question at you. Can you have an event chronicle? Can I do event audit or event genealogy? So I'm assuming they're probably talking about Pareto's and real-time versus historical event data, and maybe even things like journals, which can also be used to chronicle different types of events and issues over time. But why don't you go ahead and address that one?
Yeah, certainly, Scott. So I'll add one more thing, though, to the previous question, and that is with the remote connectivity we had to the TrakSYS solution in Alabama, Scott would feed us sort of punch list items from the operators, again, trying to get them to own the system. And our technical team would very quickly make some changes, because TrakSYS allows you to do that. So the operators would see, I really wanted this to be a little different, and literally overnight that would pop up and they could see that they were having an impact. So that really contributed to this ownership that Scott was talking about in terms of getting the stakeholders aligned as well. So back to the question. So within TrakSYS, there are a couple of functions. There's a task manager that allows you to assign track tasks and so forth. There's an electronic journal that allows operators and anybody to make notes. It could be end of shift notes, it could be anything, and it's searchable and it can be connected and emailed out or sent out as an alert and so forth. And then more on the pharmaceutical side of the applications, there's an audit track, which may be what the question is, where you can log basically each activity that is being performed in TrakSYS. So whether an operator does something or any other activity, you have a historical record of it being logged. So Scott, I think I understood that to be the question. Okay, yeah, terrific. And of course, there's a whole array of reports that allow you to focus in on things like the specific downtime events and look at them in Pareto's and mean time between failures and all of that. All right, let's just take one more question. This could be aimed at either of you, so I'll let one of you jump on it. Probably, well, I think you both have the knowledge. How much of the physical equipment was newly installed, and how much of it was retrofitted to interact with TrakSYS? So who would like to take that one?
I'll take that. In the initial phase, maybe out of the 16 pieces of equipment we did, maybe one or two were retrofitted with PLCs that were able to connect to TrakSYS. The other ones we had already ready. But like we talked about throughout this webinar, we've got a next phase where we're going to bring a whole lot more pieces of equipment online. So what we did was we determined which 16 we had to have on TrakSYS in that initial phase, and with two being not ready yet, we did retrofit those. And so when we went live with the first phase, that meant that the 16 main pieces of equipment that we wanted on TrakSYS were ready. Now, we took that knowledge, like we talked about, we've got MES phase 2 coming up in our original Alabama facility, but we took that knowledge from the first installation of TrakSYS and used that to get ready for this new facility we just opened. It's a brand new facility, brand new installation of everything. So installing the equipment here, there was going to be no need for retrofitting, because we knew what we wanted on the front end, and that's for every piece of equipment that has the actionable information coming out of it and available coming out of it to be on TrakSYS from the start. So we went into this facility with every piece of equipment being Ethernet connected to the network and with the correct type of PLC that was able to give us the information.
Yeah, I'll add to that, Scott. So as we discussed, right, Milo's T identified the machines that were Ethernet ready and machines that maybe were the most problematic, and therefore, again, this business driver, high return on investment. And in a couple of those cases, we upgraded the PLCs for an Ethernet compatible PLC, and on all of them, we put in the system tracking file. So that was the initial batch. And then this MES phase 2 basically now has demonstrated that even for the other assets where that were considered maybe lower priority, that the business value is still there to get those connected either through a PLC upgrade or adding a PLC, or there's just different methods of adding hardware that we're looking at there. So just wanted to make that comment as well.
Or even smart sensors.
Or even smart sensors, thank you.
All right, terrific. So I think that's all the questions we have time for during the webinar, but please submit your feedback and any other comments or questions into the Q&A function provided. Thank you to everyone that joined us today, and thanks to Milo's T for sharing their story. The answers to all the questions we received, not just the ones we covered, along with a link to the recording of this broadcast, will be emailed to you. If you would like to learn more about TrakSYS, please contact us at the email address shown on the screen. In addition, white papers, case studies, and videos are easy to access on Parsec's website at www.parsec-corp.com. Well, until next time, we hope you have a very successful and productive day. Bye now.